Good day everyone. Lines part 1. You have learned the basics. You have learned the equations of lines in vector form, Cartesian form, how to convert from one form to another. You also know what is standard form of a Cartesian equation. You know how to find the direction ratios, how to find the direction cosines, right? Now let us move on to more concepts and more formulae in this part. Now, if two lines are parallel, you know that direction ratios will be proportional. This you have studied in vector also, isn't it? So, if we take A1, B1, C1 or the direction ratios of one line and A2, B2, C2 or the direction ratios of the second line, then the condition for two lines to be parallel is A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Okay, very simple. If two lines are perpendicular, A1, A2 plus B1, B2 plus C1, C2 is equal to 0. You know in vectors, the dot product is equal to 0. The same thing here. Here, we will say the sum of the product of the direction ratios is equal to 0. So, these two are very simple thing. You can just take down the concept. If they give you two lines and ask you to prove they are parallel or perpendicular, use this concept and you can prove it very easily. Now let us move on to the important formulae. Next two important formulae I will now teach you. One is distance between two parallel lines. When you consider two parallel lines, the distance between them will be always equal, isn't it? At every place they will be equal. So, distance between them. First let us consider the line equations. R vector is equal to A1 vector plus lambda B vector. Another line. R vector is equal to A2 vector plus mu B vector. Here if you see, these are the points, they are different and these are the parallel vectors. Because the lines are parallel, you are getting only B vector. Okay. Here the distance given by the formula B vector cross A2 vector minus A1 vector by mod B vector the whole mod. I think you remember how to find the dot product, how to find the cross product, which you have studied in vectors. So, this is the formula. Now, look at the next one. Shortest distance between two skew lines. There I didn't give shortest distance because the distance is going to be same everywhere. Here, let me first explain what are skew lines. If you consider one plane like a board, like the notebook, etc., if two lines are there, they will be either parallel or they will be intersecting, right? But if you consider two planes in the space and if you consider two lines in two different planes, they can be neither intersecting nor parallel. Such lines are called skew lines, okay? So, skew lines are two lines which are neither intersecting nor parallel. Definitely, they will lie in different planes. They are called non-coplanar. Okay? Now, consider the two equations here. R vector is equal to A1 vector plus lambda B1 vector. R vector is equal to A2 vector plus mu B2 vector. Here the points are different. The parallel vectors are also different. Now, if you want to find the shortest distance between the two skew lines, the formula is D is equal to B1 vector cross B2 vector dot A2 vector minus A1 vector by mod B1 vector cross B2 vector the whole mod. Okay, so learn these two formulae together because here you have a cross, here you have a dot. Here you have only B vector, here you have B1 vector, B2 vector like that. So, learn them thoroughly. Okay. So, now let me give one sum. I will explain to you. Here the vector formula will be only easy. If they give the equations in Cartesian form, you convert it into vector form and then use this formula. Okay. Find the shortest distance between the two lines. Two equations are given here in vector form. First, they will not give you whether it is parallel or skew. Let us find it out. let us look at the second part. You have to check whether the I, J, K coefficients are proportional. In that case, they will become parallel lines. See here it is 1, it is 2, 1 by 2, 2 by 4, they are okay. But here you have minus 3 and minus 5. So, you know they are not parallel lines, right? So, now they should be only skew lines. So, here we want to find the shortest distance between them. Now, let us compare it with this line is R vector is equal to A1 vector plus lambda B1 vector. The second line you compare it with R vector is equal to A2 vector plus mu B2 vector, right? So now let us write what is A1 vector, what is A2 vector, what is B1 vector, what is B2 vector, okay? So now I will write my A1 vector is 4i cap minus j cap. My A2 vector is I cap minus j cap plus 2k cap. I want in the formula A2 vector minus A1 vector. Let me find it out. Okay. So let me find A2 vector minus A1 vector. So from here I have to subtract this. So I will be getting minus 3i cap. Then this is minus j, that will be plus j. So the j will go. It will get cancelled. 2k, here there is no k. So I will get plus 2k cap. This is my A2 vector minus A1 vector. Okay. Then I need B1 vector cross B2 vector. So let me write first. What is my B1 vector? It is I cap plus 2j cap minus 3k cap. The B2 vector, that will be 2i cap plus 4j cap minus 5k cap. Let us find B1 vector cross B2 vector is equal to, remember cross product is by determinants. So write here I cap, j cap, k cap. Then you write 1, 2, minus 3. Here 2, 4, minus 5. Now we have to expand the determinant. So what will I get now? I cap bracket 2 into minus 5. I will get minus 10. Minus of minus 12. So I will get plus 12. Okay, hope you remember the determinants. Right. Now minus j cap into 1 into minus 5 is minus 5. Minus of minus 6, that will be plus 6. Plus k cap into 1 into 4, that will be 4. 2 2s are 4. So minus 4. Right. So now I will be getting here 2i cap. Here it is plus 1, there is a minus, so minus j cap. This and this will go, so I will not get any k cap. Once I find B1 vector cross B2 vector, let me find out mod of B1 vector cross B2 vector. Okay, so I will be getting root 2 square is 4 plus 1, I will be getting root 5. What else you need? You want B1 vector cross B2 vector dot A2 vector minus A1 vector. So let us find it out now. I will write now B1 vector cross B2 vector dot A2 vector minus A1 vector. Okay. So now I have got 2i cap minus j cap. Then dot. What is A2 vector minus A1 vector? Minus 3i cap plus 2k cap. So now the dot product 2 into minus 3 is minus 6. Here there is j cap, there no j cap. Okay, so that will become 0. Here you have k cap, here no k cap. So that also will vanish. So we get minus 6. Now let us write the formula. What's the formula? D is equal to B1 vector cross B2 vector dot A2 vector minus A1 vector by mod B1 vector cross B2 vector, the whole mod. The whole mod is actually for the dot product can be negative, no? For that only, because any distance cannot be negative. So now we will be getting This answer we are having as minus 6. This answer you are having it as root 5. So put your whole mod. So that's all. So 6 by root 5 units. This is the shortest distance between the skew lines. Is it clear to you? So once you know the formula, first identify whether they are parallel or skew lines. After that, write the A1 vector, A2 vector, B1 vector, B2 vector. Find step by step A2 vector minus A1 vector, B1 vector cross B2 vector, then modulus, then dot. Write the formula, substitute. Okay? Now I am going to teach you two extra models which are very important. A will give you two lines and they may ask you whether they intersect or not. If that is the question, actually you can use the concept. If the shortest distance between them is 0, they intersect. If it is not 0, they don't intersect. The sum will be over. But sometimes they will ask you, show that the two lines intersect and find the point of intersection. In that case, by that method, we won't be able to find the point of intersection. So now I will teach you one method in which you will be able to show that they intersect, also find the point of intersection. Okay? So now look at this sum. Show that the lines x by 1 is equal to y minus 2 by 2 is equal to z plus 3 by 3 and x minus 2 by 2 is equal to y minus 6 by 3 is equal to z minus 3 by 4 intersect. Find the point of intersection. So I am going to teach you a new method now, right? If they give you Cartesian equation, straight away you can proceed the way I am saying. In case they give you vector equation, convert it to Cartesian and then proceed. See, certain models, it will be easy for us to go by vector, like no distance we did. In some sums, only the Cartesian way will be easier. So like that you have to choose whichever is easy and we have to follow. Now let me write the first equation, that is x by 1 is equal to y minus 2 by 2 is equal to z plus 3 by 3. See, these are all like some equal ratios like so we can equate it to some constant. I can write it as some lambda. So now if you take this and this, I will get x is equal to lambda, that is the x coordinate will be lambda. You take now this and this. So 2 lambda, that minus 2 you bring this side. So you will get y is equal to 2 lambda plus 2, right? Then take these two. 3 lambda, bring that plus 3 that side. So you will get z is equal to 3 lambda minus 3. Actually, this represent any general point on this line, okay? That is, x by 1 is lambda, so x can be just lambda. Lambda can take any value. Y minus 2 by 2 is lambda, so y is equal to 2 lambda plus 2. Z is equal to 3 lambda minus 3. So these represent the general point on the line 1. Now let us take the second line, that is x minus 2 by 2. That is equal to y minus 6 by 3, that is z minus 3 by 4, and I will equate it to some other constant mu. If you take this and this, now the x coordinate, that is that x will be now 2 mu plus 2. The y will be 3 mu plus 6. Z will be 4 mu plus 3, right? So what we have done, each line we have equated to some constant, that is lambda and mu, and we have found out the three coordinates x, y and z, that generally any point will have coordinates. Now, if two lines intersect, what do you mean? There should be a common point, isn't it? That only we call point of intersection. That means for some value of lambda and mu, the coordinates should be same. That only will be the point of intersection. That is the concept we are using. So what I am going to do? I am going to equate the x coordinates and the y coordinates. Any two you can take actually. Okay. I am taking x coordinate and y coordinate. So equating. Okay. Equating x and y coordinates. Since I have two lines, I am going to equate. Now, what will I get now? Lambda is equal to 2 mu plus 2. That will give you lambda minus 2 mu is equal to 2, right? Then take the y part, that is 2 lambda plus 2 is equal to 3 mu plus 6, okay? So, you will be getting 2 lambda minus 3 mu, that will be 6 minus 2, 4. So, it is like simultaneous equations in lambda and mu. So, now I can multiply this by 2. So, I will be getting 2 lambda minus 4 mu is equal to 4, right? So, now let us subtract minus plus minus. These two will go. I will get mu here. 4 and 4 will go. So, I am getting now mu is equal to 0. You can get any value, okay? So, I got the value of mu now. I can substitute in any one simple equation to get the value of lambda. I take this equation. So, my lambda will be equal to 2 into 0, 0, 0 plus 2. So, I get mu as 0 and lambda as 2. See, definitely, whenever you take two equations in two variables, you will be getting some value. Now, what we have to do, no? We have to take the z coordinates now. You substitute lambda is equal to 2 here and mu is equal to 0 here. If you get the same point, that means the two lines intersect. Do you follow? After getting the values of lambda and mu, substitute the values in the z coordinates. If you get the same point for the two lines, that is the z coordinate, then the two lines intersect. If you are not getting the same, that means the two lines don't intersect. Okay? So now, let me put in the first line z is equal to 3 into 2, 6. 6 minus 3, 3. So, I get the z coordinate as 3 for the first line. Let me take the second one. Z is equal to 4 mu. That is 4 into 0. So, that will be 0. 0 plus 3, that is 3. So, what I am getting? I am getting the same value, the same z coordinate. Therefore, I can say the two lines intersect, right? So, that point is answered now. The two lines intersect. Now, I want the point of intersection. Either you take the lambda value and substitute everywhere here, or you take the mu value and substitute here. Definitely you will be getting the same answer, don't bother. So now mu is easy, no, because it is 0 for me. So I will take the point of intersection is, okay, the point of intersection, the symbol I am using, no, intersect, intersection, that will be here 2 into 0 plus 2, so I will get 2. This is 0, so I will get 6. Here 0, so I will get 3. So this is the point of intersection. Is it clear? I think it's simple only, isn't it? The first line equated to some lambda. The second line equates it to mu. Find the x, y and z coordinates for both separately. Then you equate the x and y coordinates. Or you can equate y and z or x and z, whatever. Then you solve the simultaneous equations. Get the value of lambda and mu. Now, since x and y I have taken, I am substituting it in the z coordinate of both the lines. If I get the same number, if I get the same answer, the two lines intersect. That part is over. Once we prove that they intersect, to find the point of intersection, either substitute the lambda values here or the mu values here. Even the lambda I will show you, ma. Here it will be 2 lambda, okay. 2 2s are 4, 4 plus 2, 6. Here 3 2s are 6, 6 minus 3, 3. So you will get the same point. Is this model clear to you? Okay. Let us see the next model, which is very important. Find the foot of the perpendicular, length of the perpendicular equation of the perpendicular from 2 comma 4 comma minus 1 to the line x plus 5 by 1 is equal to y plus 3 by 4 is equal to z minus 6 by minus 9. Also find the image. I have taken all the possible questions here. I want to cover in this sum. Okay. Now, if you have a small rough figure, that will help you how to go about in the sum. Now, AB is the given line. Okay. P is the given point, which is 2 comma 4 comma minus 1. I am drawing a perpendicular. This Q, that is the foot of the perpendicular, right? Length means you know it is PQ length. Equation means it is equation of the line PQ. What is an image? You normally use mirror and image, isn't it? If an object is there, the image will be on the opposite side at the same distance. The same concept here. P is here. We will have the image here. That is that PQ will be equal to QR. That is the concept we are going to use. So now, what are all the things we have to find? Foot of the perpendicular, length of the perpendicular, equation of the perpendicular and image. Okay, fine. So now, if you have the figure, that will give you an idea. You know the equation of this line. When you know the equation of this line, let us first write. Okay, equation of line AB. What is the equation? X plus 5 by 1 is equal to y plus 3 by 4 is equal to z minus 6 by minus 9. In the previous model only I taught you, in a line we can equate it to some constant and we will be getting any general point in terms of that constant we have done, right? So now I will equate it to some lambda. That means I can find any point on line AB. What will be any point on line AB? 1 into lambda, that is lambda minus 5. Okay. That will be the x coordinate. Then 4 lambda minus 3. Take this and this. Okay. 4 lambda minus 3. That will be the y coordinate. Then minus 9 lambda plus 6. So, this will represent any point on the line AB. Is it clear? Now, you look at the figure. Q, the foot of the perpendicular, lies on the line AB, isn't it? So, we can take Q as this point, isn't it? So, now I will write, therefore, Q is lambda minus 5, 4 lambda minus 3, minus 9 lambda plus 6. Remember, this is one important step for us because we need Q, that is the basic for finding the rest. Now, in the figure you can see AB and PQ are perpendicular. What is the concept? If two lines are perpendicular, the sum of the product of their direction ratios is equal to 0. That is A1, A2 plus B1, B2 plus C1, C2 is equal to 0, right? So now, let us find the direction ratios of PQ. How will you find? The equation is not given, but you know the point P. You know the point Q. You have your formula, you remember, for direction ratios. X2 minus X1, Y2 minus Y1, Z2 minus Z1 will be the direction ratios if 2 points on a line are given. So now, let us find the DRs. DRs, I mean the direction ratios, okay, of the line PQ. I am going to find the direction ratios of the line PQ. You know Q is this and P is this. So, lambda minus 5 minus 2. I will get lambda minus 7. 4 lambda minus 3 minus 4. So, 4 lambda minus 7. Minus 9 lambda plus 6 minus of minus 1. So, minus 9 lambda plus 7. So these are the direction ratios of the line PQ. I can write it as A1, B1, C1 just to remember. Is this clear? If you want, here you can write the formula as x2 minus x1, y2 minus y1, z2 minus z1. That is how we found the direction ratios. Now, the direction ratios of the line AB, that is very straight because you have the equation. Not only that, first check whether it is in standard form, otherwise don't proceed. Okay, that is a condition actually. So here they are in standard form. So 1 comma 4 comma minus 9, that will be the DRs of the line AB. So 1 comma 4 comma minus 9, I can call it A2, B2 and C2, right? So now I know, since the two lines are perpendicular, A1, A2 plus B1, B2 plus C1, C2 is equal to 0. Okay, so we will proceed with that. Now, AB and PQ are perpendicular, right? Therefore, A1, A2 plus B1, B2 plus C1, C2 is equal to 0. But mark it here what is A1, B1, C1 and then write that formula. So now I will be getting 1 into lambda minus 7, okay, plus 4 into 4 lambda minus 7 minus 9 into minus 9 lambda plus 7, that is equal to 0, right? So now let me expand lambda minus 7 plus 16 lambda minus 28 plus 81 lambda minus 63 is equal to 0. So you have got here 81 plus 16 plus 1 here. So 98 lambda, 63, here 28, here 7, so 35 and 63 I will get 98. That is 0. So my lambda is equal to 1. So you will get the value of lambda when you use the concept A1, A2 plus B1, B2 plus C1, C2 is equal to 0. Okay. So now I told you the foot of the perpendicular is the main thing. You know Q. So first let us find Q. That is the foot of the perpendicular. So Q is, lambda is 1. So 1 minus 5. That will be minus 4. 4 ones are 4. 4 minus 3, 1. Minus 9 plus 6, that will be minus 3. So I got foot of the perpendicular. So one answer, right? So that is over. Now we have to find length of the perpendicular, isn't it? Now you know Q, you know P, what is given. So you can find PQ, that will be length of the perpendicular. You know the formula, root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. Now Q is this and P is 2, 4 minus 1. So now you will be getting here root of 2 minus of minus 4, okay, plus 4 minus 1 the whole square plus minus 1 plus 3 the whole square. So what will you get now? 2 plus 4, 6. So that is 6. This is 3 square, that will be 9. Here it is 2, so 4. So you will be getting here root 49, which is equal to 7 units. That will be the length of the perpendicular. So 2 answers over. Now we have to find the equation of the perpendicular. Okay, you know P, you know Q, you know the equation of the straight line in 2-point form, isn't it? So now equation of PQ, that will be, okay. So now x minus x1, we can take any point. I will take x minus 2 by x2 minus x1. So minus 4 minus 2. Y minus y1 by y2 minus y1. That is equal to z minus z1 by z2 minus z1, right? So I will be getting x minus 2 by minus 6 is equal to y minus 4 by minus 3 is equal to z plus 1 by minus 2. Actually, the direction ratios or proportional numbers, everything has a minus. So I can write it as x minus 2 by 6 is equal to y minus 4 by 3 is equal to z plus 1 by 2. Okay, so this is the equation of the line PQ. So we have found now three parts. Only we have to find the image. For that, let us use the concept that PQ will be equal to QR. I told you, isn't it? That is, Q will be the midpoint of PR. I can write P, Q and R. P is 2, 4 minus 1 and Q is minus 4, 1 minus 3. I don't know R. I will take it as some X, Y, Z. Right? Now you know Q is the midpoint. Q is the midpoint of PR, right? So now we can write, you know the formula, midpoint formula, x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. So you will get minus 4 is equal to x plus 2 by 2. 1 is equal to y plus 4 by 2. Minus 3 is equal to z minus 1 by 2, right? So now cross multiply, x plus 2 will be minus 8. So x will be equal to minus 10. Y plus 4 will be 2. So y will be equal to minus 2. Z minus 1 will be minus 6. So z will be equal to minus 5. So the image will be minus 10, minus 2 and minus 5. Is this sum clear to you? They may not ask all the 4 subdivisions. They may ask you any 2 or maximum 3. But if you know all the things, whatever is asked, you will be able to answer. So hope you have understood the shortest distance how I taught you and the 2 extra models and of course the concepts whichever I have given in the beginning also. So actually the lines, we have finished all the concepts. So then we will be going to planes and of course the lines and planes combined we will be having some models and we will be doing that. So hope the lines is clear to you. If you have any doubt, please don't hesitate. You can contact me in the WhatsApp number I have already told you, 98414 24159, or in the comment section you can write what you want and I will surely explain. Thanks for watching. Share it with your friends and classmates. Thank you.